right, thank you very much. Well, good afternoon, everyone. My name is Michel Medema. I'm a postdoc at the Information Systems Group of the University of Groningen in the Netherlands. And I will be talking about our paper on a life cycle and enabling concepts for green business process management. So nowadays, it's no longer sufficient for organizations to just be concerned with the economic performance of their business processes. Increasingly, they're required to operate in a sustainable way, which also means that they have to account for their environmental and their social impact, the so-called triple bottom line. Zooming in on the environmental sustainability, there are a number of factors that encourage and compel organizations to consider the environmental sustainability of their processes. First of all, policymakers are adopting new legislation that require organizations to both report on but also reduce the environmental impact of their activities. Doing so can also bring economic benefits to the organizations themselves. Reducing energy consumption, for example, also saves cost. Organizations may be intrinsically concerned about the environment, and issues such as climate change also raise more global awareness within society, which is then raising demand for sustainable products and services, which also provides new opportunities for organizations. The core of an organization includes their business processes, which are sets of interrelated activities that they perform in a collective way in order to achieve some kind of organizational goal and generate value for both the organization and its clients or customers. It's also by executing these processes, they're essentially directly impacting the environment. And essentially, well, business processes can have applications that range from more traditional things like handling insurance claims, financial processes in banking, but also manufacturing processes, and even, for example, cloud applications could be modeled as a business process, because it's just a set of functions that you call in a certain order to achieve a certain goal. In the context of this work, we're mainly focused on executable processes, which does not mean that everything is automated. People can still be involved, but there is some kind of software system that coordinates the overall execution of the process. Business process management is a discipline that provides organizations with concepts, methods, and techniques that they can use to manage and continuously improve their processes in a very systematic way. And it typically follows a particular life cycle that can look something like this. And for executable processes in particular, it usually starts with the process modeling phase. So process modeling is essentially creating a more formal representation of your process, and there are various standards for this. Then once you have the general process model, you refine this so that it can be executed by a software system. And then during execution, you can monitor the performance of this process. The data that you then collect can be analyzed to identify areas of improvement. And once you have found these, you can try to find a better version of the process and then implement the changes. Traditionally, in BPM, this improvement life cycle focuses very much on the economic performance. So the time of the process, the quality of the result, the cost, and usually flexibility. These are like the four main dimensions that are considered. More recently, Green BPM has emerged as a way to deal also with the sustainability side, creating what is known as the Devil's Pentagon. And essentially, this name reflects the fact that you can, in general, not optimize all of these dimensions at the same time. Usually, there's some kind of trade-off between them. And a way to quantify the sustainability dimension is through so-called key environmental indicators. These are similar to traditional KPIs, but then reflect environmental performance. So they can capture things like energy consumption, water usage, waste production, things like those. Now, the problem is that so far, existing Green BPM research and initiatives have either remained purely conceptual, or they're restricted to specific phases of the BPM lifecycle, or restrict themselves to particular environmental indicators, and usually these are either energy consumption or carbon emissions. Yes?
Sorry, big question. In terms of your process, some continuous improvement process, you're looking at your matrix and trying to improve things. How often or what is the cycle time between each process? Do you do it once a year or once every 2 weeks or once every 2 months?
The analysis and improvement, you mean?
Yeah.
I think this very much depends on the process. When it's very much automated, you can do it, well, in very short cycles, essentially. But of course, you need to support the data collection and the automatic analysis of this. If you do this in a more manual way, then of course these cycles take a bit longer. And I think it also depends on the complexity of the process.
Sorry.
No, that's fine. Yeah, so these kind of drawbacks of so far the research that is there means that organizations do not really have a full view of the environmental impact of their processes, and also lack the means to actually control this impact during process execution. So the idea of this work is to create a general green BPM lifecycle in which environmental sustainability is integrated into every phase without being restricted to particular indicators. Moreover, we want to explicitly go beyond just a mere conceptual description of this life cycle, and also take the first steps towards realizing some of the techniques and tools that are needed to support it. So the Green BPM life cycle closely resembles the traditional one in the sense that it has the same phases. But in each of the phases, additional activities may have to be performed, or the activities are performed with an explicit focus on the environmental performance. So again, starting with the modeling phase, there are two additional activities that are included here. So the first one is specifying key environmental indicators that are relevant to the process as part of the process modeling phase. So you really include these in the process model itself so that they can be used during execution to collect the performance data. The second one is the optional specification of sustainability targets. So you can essentially attach a target value to your indicator to capture like an environmental constraint that can then be used during execution to control essentially the impact. Now, none of the existing standards allow you to actually model these sustainability related aspects. And for this reason, we created an extension of BPMN, which is one of the more widely used notations for modeling business processes, in particular for environmental sustainability. So in the lower right part, you see this green part. This is essentially part of the original BPMN specification. In this case, I just took the relevant parts. So you have the activity, which can either be a sub-process, so it's a more complex thing, or you have an atomic task. And then the extension associates a set of key environmental indicators with an activity as an optional attribute. Now, the set can then contain additional, or can actually contain like the specific indicators that you're interested in. And well, just some examples that we took from the literature could kind of cover things like energy, like renewable energy consumption, non-renewable energy consumption, but also things like water usage, waste production, material usage, etc. But again, this is this is kind of a generic part. So you can also include other types of metrics like the environmental impact categories that they consider in life cycle assessment, for example. And then each indicator has a particular unit in which the values are expressed, and then the optional target value. Now, the other part of the extension is the notation. So this rounded rectangle is essentially a standard way of representing an activity in BPMN, and we kind of annotate this with the particular indicator that is associated with it in this way. And then if there's a target value, it's displayed below it. We created a prototype modeling tool for this extension. It's based on BPMN.js by Camunda. And essentially, if the process modeler selects an activity in this tool, they get this additional context menu, which you see highlighted in the green box. And then from there, they can select the indicator that they want to attach to the activity. And then they get a dialog window through which they can add the target value if they're interested in this. And then it's rendered as you see on the top. All right, so then now that we have this BPMN extension, we need to have a compatible execution monitoring environment to track the environmental performance of the indicators that we specify in the model, but also potentially to detect and predict any kind of violations of the environmental constraints, be that either the ones that we model through the target values, or maybe those that are defined based on other types of regulations. So for this, we designed this architecture, which is kind of built around an existing BPM system, which you see in the lower left corner. So after modeling the process, it's stored in a repository, and this can then be used by the BPM system to create new instances of the process. And again, this part can essentially be taken care of by any existing BPM system. Then the sustainability-related components are integrated through an event-based integration layer. And well, the core part here is the environmental sustainability monitoring component. And this essentially reacts to lifecycle events generated by the BPM system, such as new process instances being created, existing process instances either completing or starting certain tasks. And then if you combine this with the indicators in the model, you can actually calculate the environmental performance at runtime. And for this, the specialized calculator services at the bottom are used. So you can have one service essentially for each metric that you have, or even multiple for one metric if you have various methods to do the estimations of the metric. Of course, these services require additional contextual information to do the calculations. And this can, for example, be stored in a knowledge base in the form of design time information. Let's say we have a task consisting of transporting goods to a customer, and we are interested in the carbon emissions. You may want to store information about the emission classifications of the vehicle or some kind of fuel consumption behavior, which is more general about the vehicle. And then you can combine this with the distance traveled or the road taken, and then estimate the carbon emissions. Of course, they can also be provided from the environment through sensors. So, I don't know, the energy consumption of the equipment involved in execution of the activities, for example. Besides storing this information in a database for later analysis, you can also do compliance checking and predictive monitoring at runtime to either detect or predict environmental constraints. And based on these violations, you can then trigger a process adaptation. So you can change the process. And this can either target specific process instances, which are called ad hoc changes. So these are really runtime changes. Or you can really change the process model. And these are usually referred to as evolutionary changes. And the types of changes that you can think of, especially like at the ad hoc level, is, for example, scheduling the execution of a task in line with the availability of renewable energy to minimize carbon emissions. More evolutionary changes could be, I don't know, really changing the process or replacing a certain activity, maybe removing activities, changing the flow of the process, etc. And for this, we developed a prototype calculator service, in this case, focusing only on carbon emissions as a first proof of concept. And here you see a screenshot of the dashboard. So it shows one particular process instance of a fictional automotive process. And you can see the different tasks and the corresponding emissions. This was developed in parallel with the BPMN extension, so it doesn't yet use the data or the information from the process model. Instead, it relies on separate annotation files that provide information about the fuel consumption behavior of the resources involved in the activity execution. But it's not terribly difficult to make this connection and replace these files with the information in the model. Then for the analysis phase, this is relatively similar to the one in the traditional BPM lifecycle, only now with a specific focus on the environmental performance. So still the main goal here is to evaluate the performance of the process and identify areas of improvement. And for this, you can use techniques that are similar to existing techniques like process mining, process simulation, compliance checking. You can also support organizations in generating reports that they may need to comply with legislation. And you can also learn from these adaptations. So if you perform enough of them and you see the effects in practice, you can see which adaptations work best in which scenarios in terms of reducing the environmental impact of the process. Finally, the adaptation phase. Again, well, the goal is to find the, well, ideally the best alternative version of the process. But again, in this case, well, to minimize the impact on the environment. Then once you have this version, you need to actually implement the changes. And especially when they target process models, you may have to deal with the versioning of the model, maybe running multiple concurrent versions of the process, or migrating existing running instances to the new version if it's something that really need to take effect immediately, and also essentially, I don't know, existing running instances need to comply, for example, with a new regulation. But these are activities that are not really affected by the fact that we're looking at environmental sustainability. So you can reuse existing techniques for this. Now, this is what it is at this stage. But of course, there are various crucial parts that are not really accounted for in this life cycle yet. So first of all, in the BPMN extension that we have so far, we're only focusing on the activities. But that means that the process cannot, for example, react to sustainability-related events or control the flow of the process based on sustainability-related information. Another point is that before organizations can really apply this and reduce the environmental impact of their processes, you need to attain full lifecycle coverage. So you really need to develop all the tools and techniques to support the activities of all of the phases. This was not really the goal of this paper, but it is ultimately important, of course, to really unlock the full potential of the life cycle. Another point is that by looking at the activities in the process, you're mainly focusing on the direct impact on the environment. But of course, organizations also make a potentially large amount of indirect impact on the environment. They rely on suppliers for their materials. They rely on organizations for certain services, which they outsource. They have IT equipment, for example, to actually run their processes, which is not really linked to any particular process. Also, employees within the organization, they travel, I don't know, they use equipment, etc., which is not, again, directly linked to any one particular process. And accounting for this indirect impact is not only important to have a better and kind of complete view of the impact, but also to prevent this from being kind of pushed outside of the boundaries of the organization where you cannot measure or observe it. Because of course, otherwise you can outsource activities, and then from the organizational perspective, it looks as though you're improving your environmental performance, whereas all you're doing is just moving it somewhere else. And this may not necessarily be a bad thing, because another organization may be more efficient at doing a certain task. But it may also be that you outsource it to some organization in a country where they don't have very strict regulations and where actually the environmental impact is way worse than what the organization was doing. But it still would then look as though you're improving. Finally, this Green BPM lifecycle only looks at and kind of considers improving the environmental performance of the process. Of course, it's still an organization and they have a business to run. So they ultimately also need to consider their economic performance, right? It's not realistic that they just improve their environmental performance. And as I mentioned in the beginning, sustainability has essentially also a third dimension, namely the social dimension, which should ultimately, ideally also be covered, and solutions should be developed also for this dimension so that organizations can truly operate in a sustainable way and make the right trade-offs in terms of these three dimensions. But so these are some of the points that we want to work on next, starting with the first two, and then the last two are a bit more long-term. But for those, we also think that we can learn a lot from, for example, life cycle assessment, where they already have ways to quantify and consider, for example, this direct impact, but also quantify social impact of products, but also processes. So we hope to also learn from that and maybe make this connection. So yeah, thank you.